Hi guys, Mr. Martin back here again with today's video on how to prove lines are parallel. Let's get started. Alright, the first thing we're going to do is we're going to establish a postulate that's going to set the stage for this video. Okay, the postulate we're going to use today is called the corresponding angles converse. I want you to notice first of all that postulate 16 is the converse of postulate 15. Postulate 15 said if the lines are parallel, then corresponding angles are congruent. Okay? We're going to flip those two statements and say if corresponding angles are congruent, then the lines have to be parallel. Pretty easy switch. Switch the hypothesis and the conclusion, you now have the converse. Okay? Let's use this example. In an example. Okay? I have a situation where I want to find the value of x that will guarantee line M and N are parallel to each other. Well, we know from the postulate, if we can make those two angles congruent, then the lines have to be parallel. So we're just going to take those two expressions and set them equal to each other, because we know congruent angles have equal measures. By a couple quick algebraic steps, we can show that x equals 20. So if we go back up to this angle and we put in a 20 for x, we get 60 plus 5, we get 65. So we know that those two angles have to be congruent. If those two angles are congruent, then that makes line M and N parallel to each other. So now instead of starting with lines being parallel, we're going to prove that the lines are parallel. Okay, before we had lines that were parallel and we learned something about the angles. Now we're going to start with the angles and learn something about the lines. Alright, let's move on and get some theorems established. Okay? The first one is the converse of the alternate interior angles theorem. Okay, the converse says if the alternate interior angles are congruent, then the lines have to be parallel. That's the converse of the theorem from last lesson. Next theorem. This is the alternate exterior angle converse. This one says if the alternate exterior angles are congruent, in this case we got angles 1 and 8 being congruent, then if those are congruent, the lines must be parallel. Alright? Last one. It is the consecutive interior angles converse. This one says that if the consecutive interior angles, in this case we've got angles 3 and 5 being congruent to each other. So, sorry, not congruent to each other. We got them being supplementary. And we know if they're supplementary, the lines must be parallel. Okay? So don't get confused. The first three were congruent angles. This one is supplementary angles. Alright? Let's prove the alternate interior angles converse. I want you guys to start thinking about being able to prove every theorem. Okay? Alright, so we're going to start with the given information coming from our hypothesis. So our hypothesis in this example is that the alternate interior angles are congruent. We're going to say that that is our given information. That's coming from the hypothesis. Our conclusion is going to be the statement that we're trying to prove. This is coming from the conclusion. So the hypothesis is the given information. If we know the hypothesis is true, then we're trying to prove the conclusion is true. Alright, so let's set this up. Okay, there's my given, there's what we have to prove, and here's a picture of the situation. So we got angles 4 and 5 being congruent. Okay, so we're going to add angle 1 to this. And the reason why I'm going to add angle 1 to this is because I want to establish corresponding angles. Okay, so let's look at the proof. All right. So we know that 4 and 5 are congruent to each other because that was given information. Okay, that's an easy one. First line is always given. Okay, we know 1 and 4 are congruent to each other because they're vertical angles. Okay, now because of those two statements, we've got 4 congruent to 5 and 4 congruent to 1. We know, thanks to the transitive property, that 1 must be congruent to 5. So now we've got 1 congruent to 5. So 1 and 5 are congruent. Since 1 and 5 are congruent corresponding angles, we know that the lines must be parallel. That's a quick slam dunk for a proof there. Took us 4 lines to prove that those two lines have to be parallel. Once we establish that corresponding angles are congruent, then we know the lines have to be parallel. All right, let's move on. I want to introduce you today to what's called a paragraph proof. Okay? A paragraph proof is what it says. It's a proof written in paragraph form. Okay? So we're going to write a paragraph proof. Okay? We're going to, as it said, use sentences, words, to describe why we know something is true. That's contrasted to what we had before was the 2-column proof. Okay? It uses a column of statements and a column of reasons. And it's not maybe necessarily easy to follow if you're not real familiar with 2-column proofs. But if I write you a paragraph and explain to you in words and sentences why things are true, then I think it might be a little bit easier to follow. So let's take a look. Okay? Let's set this up. So we're trying to decide how to prove this. So we look at the diagram and we want to make a plan. Okay? So the diagram suggests that we consider angles 1, 2, and 3. They're on the diagrams. They must have something to do with each other, right? So let's look at those. Okay? So we've got lines R and S parallel to each other. So remember, we marked parallel lines with an additional arrowhead. Okay? We got line Q, which in this case is going to be our transversal. Okay? So, lines 1 and 2 are corresponding angles. We know they have to be congruent if we have 2 parallel lines cut by a transversal, right? Okay. So, we got an idea of kind of where we're going to go, okay? So, if I can prove that 2 and 3 are congruent to each other, then I can prove now that P and Q, the other 2 lines, have to be parallel to each other because now R will become my transversal. Okay, so if we have now P and Q, okay, these are our lines, and now R is my transversal. If we can establish something like alternate interior, alternate exterior, corresponding angles, then we will be able to prove that P and Q, all right, are parallel. Let's go to the proof. So we're going to just write it out in words. Okay? We're going to say it is given that R is parallel to S. So by the corresponding angles postulate, 1 must be congruent to 2. All right? Then let's move on to, since 1 is given to be congruent to 3, and 2 is also congruent to 3, by the transitive, then 2 is congruent to 3 by the transitive property. Again, we've got 1 congruent to 2. Angle 1 is congruent to angle 2. Angle 1 is also congruent to angle 3. The transitive property says that angle 2 must be congruent to angle 3. We now have alternate interior angles that are congruent. So now we know by the alternate interior angle converse that P and Q must be parallel to each other. All right? Just an example of a paragraph proof. Something I want you to think about and compare and contrast that to a 2-column proof. In paragraph proofs, we use transition words such as so, then, therefore, to help make a clear transition from one thought to the next. So pay attention to those words as you're writing paragraph proofs. All right, let's look at the transitive property of parallel lines. We said before that if two angles are congruent to the same angle, they must be congruent to each other. This says the same thing. If we've got P parallel to Q, P is parallel to Q, and Q is also parallel to R, then we know that P must be parallel to R as well. Okay? The one arrow on there indicates that they're congruent to each other. Two arrows indicate that they're congruent to each other. We know that all three of these are congruent to each other, so we could put two arrows on all three lines because we know that all three of those lines are parallel to each other. All right. That's all I got for you today. Hope you got that all in your notes. Come ready to work on some examples in class on Friday, and I'll talk to you guys later.